Okay, now that we've looked at two examples for the company, we're going to look at M&Ms and we're going to determine if the percentage of each color in M&M's package is as stated. So we know that an online search, we're on page 7 of the lecture notes, an online search revealed that M&M's milk chocolate candies, the proportions are 30% brown, 20% yellow and red, 10% of orange, green, and blue. And we're going to test if this is true. So the first thing we're going to do is input the data we know. So we know the colors, blue, brown, green, red, orange, and yellow. And we know the frequency of each, 13, 28, 64, 32, 52, and 11. That should sum to 200. So we know we have 200 M&Ms, and the specified proportion is 0.1, 0.3, 0.1, 0.2, 0.1, and 0.2. So that should sum to 100%. Now, we can just format this a little bit. Now we've inputted our data for the sample of 200 with the alleged proportions, and now we're going on our test. So similarly, we have different columns: category, observed, test proportion, expected, and contribution to chi-squared. And we're just going to wrap this text so that it will be formatted well, so that everything looks nice. Okay, so we know our categories are from 1 to 6, so we can just input 1 to 6 here. And our observed counts are we're just going to take this from the table up here. So we're just going to reference cell B2, and that should tell us 13. And we're just going to fill in this series down below. So it should reference each of our cells. And same thing for our proportion. We're just taking that from right up top. So just fill these cells down below, or copy and paste them. Now for our expected, we're just going to take our test proportion for each category and multiply this by the sample size, which we know to be 200. So we lock that cell in, we have 4. We get our expected of 20 and bring this formula down, and we can see that for each one, the expected is typically based on our test proportion. Now for our contribution to chi-squared, we're going to take our observed minus our expected, square this value, divided by our expected, and we should get 2.45 for the first one. We copy this down and format to 4 decimal places, and we see that we should match exactly with what's on the notes. Now if we sum these values, we'll get our chi-squared of 190. So let's start filling in our inputs. We know that our n is going to be just 200, so we can reference that. Our chi-squared value is 90. Our degrees of freedom in this case, we know we have 6 categories, so we can take 6 minus 1, it should be 5, and we're actually already ready to run our test. So our p-value is going to be, using the chi-dist formula, we're going to take our chi-squared value and our degree of freedom of 5, and we know that this number is very, 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 very small. You can see that if we put it to, let's say, 15 decimal places, it's still 0.000. So we can be certain that it matches with p-value on the note sheet. So we just successfully completed this test, and we know that the proportions suggested um, these suggested proportions are not accurate based on our test.